let's look at this problem. Two cards are drawn from a poker deck. The first card is a diamond and the second card is a heart. And the problem A is asking us to find this probability without replacement. That means after drawing the first card, we don't put it back. And then we draw the second card. So here we have two cards. And the probability of the first card times the probability of that second card is equal to the probability we're looking for. Okay, so first let's find out the probability that the first card is a diamond. We know it's 1/4, right? So for every 4 cards of the same kind, one of them is a diamond. So that's 1/4. Or you can think of it as 13 over 52, which is also 1/4. Okay, so that's the probability that the first card is a diamond. Now remember, this is without replacement. So for the second card here, you are 1 card less. So it's out of 51 cards. Since we know the first card is a diamond, we know it's not a heart. So we still have 13 hearts. So it's 13 out of 51 is the probability that the second card is a heart. So the answer to the question A is 13 over 204. Now let's look at question B. What is the probability that the first card is a diamond and the second card is a heart if the cards are drawn with replacement? Okay, similarly, it's still the probability of the first card times the probability of the second card is equal to our answer. What is the probability of the first card is a diamond? Well, it's also 1/4. This time I'm going to write 13 over 52, or 1/4. Right, so since this time is with replacement, so after the first card is drawn, I'm putting that same card back. So for the second card, the pool is still 52 cards. And what is the probability that that card is a heart? It's also 13 out of 52. So if you simplify it, it will be 1/4 times 1/4, which is 1 over 16. When it is without replacement, the event of the second card is a heart is dependent on the first card. That means the second probability is dependent on the first probability. And for the second problem, problem B, since it's with replacement, these two probabilities are independent. That means the probability of the first one doesn't affect the probability of the second one, and vice versa. And I hope this is helpful, and I will see you in the next video.